Hello everyone, welcome to Gate Academy. First of all, please share the link as much as possible. After very long time I am on YouTube. You all know that health issues are always with me. So that's why I was not on YouTube for very long time. Okay. So today we will understand the basics of recursion. See, recursion is a very good tool. Recursion is a very good tool. Recursion itself is a very good tool, but indirectly, if you know recursion, that means you know various topics. For example, dynamic programming. In case of dynamic programming, first you have to come up with a recursive solution, then you go for a dynamic programming concept. For example, if you know recursion, you know backtracking very well. If you know recursion, you know DAC, that is divide and conquer. You know merge sort, quick sort, all are based on DAC. So recursion is very much important for computer science graduate. Am I right or not? Am I right or not? Please share as much as possible. Believe me, today I will discuss only the basics, ABCD about recursion. From tomorrow onwards, we will solve problems based on recursion. Good evening everyone. Good evening Shivam. Good evening Sunny. Good evening Sparrow. I know that parallelly COA lecture is running on another channel. That's the reason that very less viewers are there, but no problem at all. This is my very first lecture and I am expecting to increase this count. I know Sparrow, I know that COA is going on parallelly. No problem at all. Okay, let's start. What is recursion? What is recursion? I want everyone to reply what is recursion. What is recursion? Sparrow, from tomorrow onwards, I will change the timing. But as of now, let us focus on study. Let us not focus on how many number of students are watching me and all this. So someone is saying function calls itself doing the same task repeatedly. Okay, very good. See, in basic terms, what is recursion? Whenever an operation is defined in terms of itself, then it is said to be recursion. Whenever an operation is defined in terms of itself, then it is said to be recursion. I will take two examples. My oldest examples, I always used to give these examples from last 6 to 7 years. But I know that these examples are the best example. So let me take the very first example. Example number 1. Let us suppose there is some word whose meaning is not known to you. There is some word whose meaning is not known to you. For example, let me take that word as cyborg. And in order to know the meaning of this word, you are looking into the dictionary. What you are doing? The operation you are doing is looking into dictionary to find the meaning of this word. I am talking about a dictionary from that contains English to English translation. That means let us suppose the meaning of this word is written as amalgamation of man and machine. Again, sir, we are looking for the meaning of this word, but the definition of this word contains a word whose meaning is again known to us. For example, let us suppose, sir, I don't know, or any word, the definition of this word contain another word whose meaning is not known to you again, then what will you do? Tell me, what will you do? Be honest, what will you do? Sir, we will again look into the dictionary to find meaning of this word. Am I right or not? Sir, we will again look into the dictionary to find meaning of this word. Am I right or not? And let us suppose, unfortunately, the definition of this word in dictionary contains another word whose meaning is not known to you. Then again, what will you do? Sir, we will look into the dictionary. We will look into the dictionary to find the meaning of this word. I am just taking an example so that recursion, you will understand recursion. Please don't do something like that we will Google it, sir. I know you will Google it. Okay, but don't write it over here. Just try to understand the concept behind recursion. Is that okay? Sir, how many such words we will look? Do we need to look all the words in the dictionary? No, sir. The words that came in this path. Am I right or not? Let us suppose the situation is like this. Sir, the definition of this word contain a word whose meaning is not known to us. The definition of this word contains a word whose meaning is not known to us. The definition of this word contains a word whose meaning is not known to us. Try to understand. Again, we will look into the dictionary. Now let me ask. Do you know the meaning of this word? No, sir. When you get to know the meaning of this word, whenever you know the meaning of this word, that means this word is waiting for the answer of this word. Am I right or not? When you get to know the meaning of this word, sir, whenever we get to know the meaning of this word, that means we are able to get the meaning of this word. Am I right or not? So this one is waiting for this one is waiting for this. Done to everyone? Done to everyone? So what is the task? We are looking into the dictionary to find meaning of one word, but in order to find meaning of this word, we are looking into the dictionary, but the meaning of this word contains another word whose meaning is not known to us. And in order to find meaning of this word, we are again looking into the dictionary to find meaning of this word. Isn't it recursion? Isn't it recursion? Sir, let us suppose the meaning of this word is known to us. That means the meaning of this word is known to us. That means the meaning of this word is known to us. And that means the meaning of this word is known to us. Done? I hope a little bit idea, 1% of what is recursion is okay to everyone. I am not saying that recursion is over. I am saying 1% of what is recursion is over. Am I right or not? Let me take second example. Please let me take second example. Okay. Let us suppose Dandy sir invite all the students for award ceremony for gate 2022. Dandy sir invite all our students at Bhilai Center. Every student reach Bhilai Center. Sir, thousands of students are there. and Dhande sir asked me, Pankaj, please count how many students are there. Please count how many students are there. Big trouble. Student knows me and little bit respect is there. So what I used to say, please make a queue. Student, make a queue. Try to understand what is the situation. Some students are there. They are standing in a queue. How many students? No one knows. There could be 4,000 students. There could be 5,000 students. I don't know. Try to understand. I don't know. This is me. This is me. A queue is maintained. A queue of students is maintained. Please keep on sharing. Please keep on sharing. This example will clear all the concepts of recursion. Now I have many ways to count the number of students. Try to understand. The first way is, while standing at my position in front of that queue, I will count like this: 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Tell me, is it a feasible way to count the number of students? Is it a feasible way to count number of student? I am a short height person. Sir, it may be there that some of the students are hidden behind a longer person. Am I right or not? Am I right or not? So the first way is not good. The first way is not good. The first way is not good. Sparrow, but this is the best example. This is the best example. Is it okay to everyone? Is it okay to everyone? Done. The second thing I can do is I will travel through the queue and counting the number of students like this. I will travel through the queue and I will count 1, 2, 3, 4, 5, 6. Again, is it a good way to count the number of student? Is it a good way? Yes, it is a way to count the number of student, but it is again a harder way. For an old person like me, 40+ person, is traveling through the queue and counting the number of students. Okay or not? So it is a hard way to count the number of students. Now try to understand what is the problem. Dhande sir asked me to count the number of students. Okay. Do I know how many students are there? No, sir. But can I take help of any one of them? Yes, sir. I will ask this student, tell me the number of students sitting behind you, including you. Try to understand. I will ask this student to tell me the number of students sitting behind you, including you. Tell me, do he or she knows the number of students sitting behind him or her? Does she knows or does he knows the number of students sitting behind him or behind her, including him or her? No, sir. No, sir. Again, this student ask the person sitting behind him. Let us suppose all of them are boys. This student again ask the person sitting behind him. Tell me the number of students sitting behind you, including you. Again, this student also don't know the number of persons sitting behind him. So again, he will ask this student sitting behind him, tell me the number of students sitting behind me, sitting behind you. And this procedure there. this procedure keeps on going. So let me explain what will happen. Tell me among all these students who knows the answer, that how many students are sitting behind him including himself. Among all these students, which student knows the correct answer? This one no, 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 this one no. Only the last person knows the answer. Only the last person knows the answer. Am I right or not? Only the last person knows the answer. The last person says, no one is sitting behind me and I am a human being, so my answer is 1. That means he will answer 1 to the person sitting in front of him. Now, what is the answer this student gets? This student says, okay, one person is sitting behind me and I am also a human being, so my answer is 1 plus 1, so my answer will be 2. Am I right? Please try to understand recursion. This is the last example and believe me, you know recursion very well from this example. Okay. Now, this student says, okay, I get to know that 2 students are sitting behind me and I am also a human being, so my answer will be 3. Similarly, this student says, okay, 3 persons sitting behind me, so my answer will be 3 plus 1, 4. This student says, okay, 4 persons are sitting behind me, so my answer will be 5. Try to understand. This person says, okay, 5 students sitting behind me, so my answer will be 6. This will say, my answer will be 7. This will say, my answer will be 8. And I get to know that how many students are there. Am I right or not? Am I right or not? Am I right or not? Sir, that means try to understand. Just like the one addition, only one addition. Try to understand. Try to understand. Sir, whatever answer this student gets, it will add 1 and transfer to the next student. Am I right or not? Am I right or not? So in recursion, various robots, various people work together. Everyone perform only a small piece of work done, and the rest is handled by recursion. The rest is handled by recursion. A small work done is done. A small work done is performed by every student. A small work done is performed by every person. A small work done is performed by every recursive call, and the remaining work done is performed by recursion. Did you get that? Did you get that? Did you get that? Tell me, if there is only one student, do I need to perform any of this activity? If there is only one student, do I need to perform any of the activity? Oh, tell me the number of students sitting behind you. Oh, tell me the number of the person sitting behind you. Sir, if there is only one person, you can answer directly. Answer is 1. So try to understand. Try to understand. Whenever you write code for recursion, whenever you have any recursive function, please try to understand. Please try to understand the concept only. Sir, there are 2 cases. There are 2 cases. If the input is small, then we can answer directly. No need to perform any recursion. No need of recursion. So we used to say this is easy case. This is easy case. This is base case. So try to understand, in recursion there are at least two cases. The first case is said to be easy case, when the input is so small that we can answer directly and we don't need any help of recursion, we don't need any kind of recursion. Is that okay to everyone? Is that okay to everyone? Is that okay to everyone? I will change the timing of COA or the timing of my lecture. I am facing this problem and I know why the number of viewers are very less. I know that the premiere of COA is going on in parallel at other channel. Okay. And what is the second case? Second case is the tough case. Try to understand. I am saying there are at least two cases. At least two cases. I am not saying exactly two cases. There are at least two cases with every kind of recursive function. First one is a small input. First one is called as easy case. Second one is said to be tough case, complex case. We cannot answer directly. We cannot answer directly. We cannot answer directly. So what we need? We need recursion. We need recursion. And we know how recursion works. Sir, every function call, every recursive call perform some small unit of work done and remaining task is performed by recursion. Are you getting me? Are you getting me? Sir, in first case, no recursion is required. You can answer directly. In second case, recursion is required. But what is recursion? Sir, recursion means every recursive call performs some small unit of work done and remaining task is performed by recursion. Is that okay? Is that okay to everyone? Sir, small input, large input. Small input, large input. Done to everyone? Done to everyone? Is the integer n is greater than equal to 1. For example, input is 3. What is the output? The output would be star star star. Okay. If the input is 5, the output would be star 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 star. If the input is 1, the output is star. That means, sir, the input is a number and we need to print star those many times. Now, many of you will say, sir, we will use a for loop, easiest task. Why to go for recursion? So, my dear friends, just for understanding recursion, let's forget that we know any loop. We don't know any loop. We don't know for loop, we don't know while loop, we don't know do while loop. Just to practice recursion, forget loop. Is that okay? Now no one among us knows anything about any loop. We need to solve this using the concept of recursion. Now, what is recursion? Sir. Let us suppose I am saying that print is the function that will take input as number, and this function is supposed to print n times star. This function is supposed to print n times star using the concept of recursion. Is that okay? Is that okay? Is that okay to everyone? See, from tomorrow we will solve problems from Geeks for Geeks or HackerRank or any other coding platform. Give me first 2 days, 1 or 2 days to build the foundation. Then we will run on that road. As of now, tell me whether recursion is okay to everyone or not. Recursion is okay? Okay. Now, sir, let us solve this problem using recursion. So, tell me what is that small input? What is that small input for which we can answer directly? What is that value? What is that small value of n for which you can provide the output directly without any loop, without any recursion? Tell me. Tell me. Everyone is agreed on the value 1? Do I have the consent of each and everyone who is watching this video that the small value of n is 1? Tell me. Please, yeah, don't demotivate me. Sir, if the value of n is 1, we know, just print 1 star. So, let me print that star. Printf star. Okay. If this is not the case, see, what is this? This was the easy case. This was the easy case that can be answered directly. Okay. If this is not the case, what does that mean? Sir, if this is not the case, that means now we have tough case. Or can I say large input? Sir, input could be 1000, input could be 5623. I don't know what is the value of input. So, recursion is required. So, tell me, sir, in recursion, every recursive call, here, I am going to write the small piece of work done that is performed by every recursive call. So, what is that small piece of recursion that must be performed by every recursive call? We have to print n number of stars. What is that small piece of work done to be performed by each recursive call? What can we say? Tell me. What is that small piece of work done to be performed by each recursive call, and remaining will be handled by recursion? Tell me. Sir, if there are n star to be printed, each recursive call will print 1 star. Tell me, let us suppose the value of n is 1000. If recursion is required, I am saying something like this, that every recursive call will print 1 star and remaining 999 will be handled by recursion. Am I right or not? If the value of n is 1000 and this is the very first call, please try to understand. We are saying that this recursive call will print 1 star and remaining 999 will be handled by recursion, or remaining n minus 1 will be handled by recursion. Am I right or not? Am I right or not? Try to understand. Sir, if this is the call for printing n star, every recursive call will print 1 star and remaining n minus 1 will be handled by recursion. Imagine recursion is a magical function. Am I right or not? So now tell me which function will print n minus 1 star? Sir, print function is that magical function we are already using to print some number of star. So in order to print n minus 1 star, can I go with print function? Yes, of course. So let me write print function to print n minus 1 star. Now try to understand this function. Please try to understand this function, whether it is okay to everyone or not. Sir, is that okay to everyone? Is that okay to everyone? Should I write the code? Should I write the code for this, or everything is okay? Do you want me to write the code over here? Do you want me to write the code over here? Just like I used to code in my placement series, do you want me to code over here? Okay. So we will code good examples. Okay, this was an easy example, so I am not writing the code over here. Okay, let us understand with another example. Example number 2. Now understand recursion in this way also. If you want to learn recursion, you must know everything about recursion. See, what is recursion? In case of recursion, whenever you are writing code, always assume that you know the answer of a smaller size input. Always assume that you know the answer of a smaller size input. Because what is recursion? In recursion, we take a problem, we break it into a smaller size problem. Try to understand. If I say the input is n size, what could be the smaller size? The smaller size could be n minus 1, a smaller size could be n by 2, a smaller size could be n minus 2, a smaller size could be n by 3. What I am saying, in recursion, we take a problem, we break it into a smaller size problem, we keep on breaking it into a smaller size problem until we reach a point where we cannot further break a problem. So try to understand. Sir, in case of recursion, always assume that you know the answer of a smaller size problem. 50% problem is solved. 50% problem is solved. You always assume that I know the answer of a smaller size problem. Done? Is that okay? Is that okay? Is that okay? This is the key point you must know. This is the key point you must know. Okay, sir. Okay. Now, let us understand example number 2. Input is a number n greater than 0. Input is a number n greater than 0. Try to understand. Input is a number n greater than 0. What is the output? Let's see. If the input is 345, the output is the sum of digits, that is 3 plus 4, 7 plus 5, 12. Okay. If the input is 9987, the output would be 18 plus 15, 33. Okay. If the input is 9, the output is 9. Did you get the problem? Did you get the problem? Input is a number greater than 0. Input is a number which is greater than 0. The output is the sum of digits of that number. The sum of digits of that number. So tell me, how can we write code for this function? How can we write code for this function? Sir, first of all, let us suppose sum is the name of function that takes any number and it will return the sum of digits of the number. Now tell me, as per recursion, sir, there must be easy case. Base case that can be answered directly. So what is that base case? 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 What is that easy case for which you don't require any recursion? Sir, if there is single digit, we can return the output. If the input is 9, output is 9. If the input is 7, output is 7. If the input is 2, output is 2. Am I right or not? See the problem statement. N is greater than 0. So I am assuming the input is greater than 0. Okay? I am assuming the input is greater than 0, or if you want, let me take it as unsigned int n. Okay? So now tell me what is the input. Sir, if the value of n is less than or equal to 9, then directly return the answer as n. Is that okay? Is that okay? Else means we require recursion. Now tell me, if the input is 345, how could be this problem can be explained in terms of itself? An operation defined in terms of itself. Or see, there are two ways. First, an operation defined in terms of itself. So I am saying we need to find sum of 345. We will take the sum function will take this value, and this sum function need to provide the sum of digits. So what can we do? Sir, there are two ways. First, when we say recursion, whenever an operation is defined in terms of itself. So tell me, can I define this sum of 345 in terms of itself? If yes, then how? Sir, what we are supposed to find? Sum of digits. That means we need to find sum of all digits. Every recursive call must perform some unit of work done. Sir, here what is the work done? We need to find the sum of all the digits. So what is that small unit of work done that must be performed by every recursive call? Think carefully. Don't mug up things. Sir, every recursive call will provide one addition. Now tell me, in C programming or in any programming, how can we extract one digit? and what is that digit, last one or first one? Can I extract last digit or first digit easily? Which digit can be find easily? Sir, last digit can be find easily. Am I right or not? So first recursive call will say, okay, I will find the last digit like this, 345 mod 10. Okay, that means what is that? 5 plus. See, every recursive call will perform one addition. So this last digit plus what is remaining? Sir, perform sum on 34. How can I extract 34? You know it very well. 345 divide by 10. So what I am saying is, no matter what is the number, if the number is 3496, we will say 6 plus sum of 349. Am I right or not? Am I right or not? Am I right or not? Second way to understand this, what I told you, always assume that you know the answer of a smaller size problem. So if someone says find the sum of 1, 2, 3, 4, think over it. Sir, if I know the answer of this or the answer of this, can I tell the final answer? Of course. If you know sum of 123, the only thing you need to do is add 4. Add 4. In this case, you need to find 1, but it is not easy. Why? Because extracting first digit of a number is complex. That is why drop this idea. Always think like this. Always think like this. Don't mug up things. I am here. Is that okay or not? Is that okay or not? See, don't worry about count. If I will provide quality content, the count will be 170 in few days. Don't worry. I know that. This is the minimum count in my entire life, but I don't care. Why? I am providing the quality content. I know that. Now, sir, that means sum of any number n. How could I extract last digit? It is n modulo 10 plus sum of remaining. See, I hope you remember. Every recursive call performs some task and remaining task is performed by recursion. So, how we can find the remaining number? N by 10. It's okay or not? That means, sir, now we know the answer. So, what should I write in the else part? What should I write in the else part? Tell me, what should I write in the else part? Sir, you must write n modulo 10 plus recursively solve for n by 10. Done? This is the else part. This is, tell me whether it is okay to each and everyone or not. Whether it is okay to each and everyone or not. Sound good or not? Are you able to understand recursion conceptually? Are you able to understand recursion conceptually? I am not saying you will solve all the coding problems. I am asking only that, are you able to understand recursion conceptually or not? Okay, Tarun Kumar is saying, sir, please dry run it. Okay, Tarun Kumar, please check, please check. Let us suppose we say sum of 1, 2, 4, 9. Okay, sir. Because n is not less than equal to n, else part will execute. Else part is saying n mod 10. So 1, 2, 4, 9 mod 10 is 9 plus the value of this is 9 plus sum of 1249 divided by 10. 1249 divided by 10 is 124. Now, sir, for addition, two operands must be there. One operand is ready. Where is second operand? We need to solve, we need to evaluate. So tell me how we can solve sum of 124. Sir, sum of 124 is nothing but 124 mod 10, 4 plus sum of 124 divided by 10. So it is a 12. Now sum of 12, the value of sum of 12 is 12 mod 10. So 2 plus sum of 1. Now the value of sum of 1 is 1. The value of sum of 1 is 1. So 1 plus 2, 3 is the value of this. So 3 plus 4, 7 is the value of this. 7 plus 9, 16 is the answer. Is that okay? Is that okay? Is that okay to everyone? Is that okay to everyone? Okay. So from tomorrow I will change the timing. From tomorrow I will change the timing. Tell me what time is most suitable. What time is most suitable so that everyone can watch and enjoy. Tell me the timing before 8 p.m. morning. Okay, morning time is suitable. Morning time is suitable to everyone. See, from 7 to 8:30 not possible. Sparrow is saying 6 to 8 p.m. Okay. सर बस पैरेलल में कोई और नहीं होना चाहिए. ओके 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 please keep on sharing the link. I will change the timing for sure. From on 5th of May we are launching our English recorded course, that means PD, GD, tablet and VOD. So please keep on sharing the link. Okay, I will change the timing, don't worry. For today that's all. Let me end the session because this is the very first session. I don't want to exhaust anyone. So please watch this video again and again so that from tomorrow we can go for good problem. We will solve very good problems. Okay, we will understand recursion in detail. Sparrow, if you are having some doubt, please message me on 9627901605. Please WhatsApp me your doubt if you are having anyone. Okay, please share the video. Please share the link. Please share the link. Okay, please share the link. Please keep on sharing the link. The faculty gets demotivated if the number of count is so much low. Okay. So that's all for this session. Bye bye. Take care.